talk about the chemical properties of alkenes and alkynes, whereby we are going to look at hydrogenation, halogenation reactions, combustion, and then oxidation. So right away, let us begin by looking at hydrogenation in alkenes. So we all understand that the double bond on the alkene is the functional group. It means that this is where the reaction is taking place. Alkenes react by opening up the double bond. Then if we have a hydrogen atom, it will come and then attach itself to a carbon that had the double bond. So for the case of an alkene like ethene gas, when you react ethene gas with hydrogen gas, first of all, the double bond is going to open. Then you will be able to, one hydrogen will attach itself to carbon number 1, as you can see here. Then another one to carbon number 2. So we'll end up by getting an ethane. So in general, you can be able to say an alkene, when it is reacted with hydrogen, you obtain an alkane. Now, for the sake of alkynes, an alkyne like ethine, when you react it with hydrogen gas, you first of all obtain an alkene, which is ethene. Then you add another hydrogen gas, you obtain an ethane. So in other words, in general, we can be able to say an alkyne plus hydrogen, you obtain an alkene. Then you add another hydrogen gas, you obtain an alkane. So that is the general equation for the hydrogenation reactions for alkenes. Now, we want to move on to look at halogenation reaction. Now, when we look at halogenation reactions, we talk about reaction between alkenes and alkynes with compounds like fluorine, chlorine, bromine, and iodine. We call them halogens. Now, when we take a compound like ethene, then we react with chlorine, we will be able to, the double bond first will be able to open like this. Now we replace the hydrogens. Now, one chlorine, because chlorine looks like this, now one chlorine will attach itself to carbon number 1 and then another one to carbon number 2. So we will end up having a compound, we call it 1,2-dichloroethane. So in general, we can say that an alkene reacted with a halogen, you end up getting a haloalkane. That is now the general equation. Now, let us consider an alkyne and see how the reaction is taking place there. When we look at a compound like ethine, let us react it with a halogen like chlorine. Now, here we will have, first of all, the triple bond opening up to remain with a double bond. So it will be like this. One chlorine will attach itself to carbon number 1 and then another one to carbon number 2. The reaction will not stop from there. It will continue. Then the double bond will open to be a single bond. So we'll end up getting a compound we call 1,1,2,2-tetrachloroethane. So in general, we can be able to say that an alkyne plus halogen, you obtain an alkene first, then add another halogen, then you obtain an alkane. That is simply what happens to halogenation in alkenes and alkynes. Now let us move on to combustion. Now, under combustion, we usually talk about the reaction between alkenes and alkynes with oxygen. So, when we react a compound, any hydrocarbon with oxygen in alkenes and alkynes, we usually talk about the reaction between alkenes and alkynes with oxygen. And when you react a hydrocarbon with oxygen, you end up getting carbon dioxide and water. So, let us see. If we have a compound like ethene, then we react it with oxygen gas, we will get carbon dioxide gas plus water, liquid. These are the only products that are obtained when you react an alkene, this is ethene, with oxygen gas. The same thing happens to a compound like alkynes. Let's take a compound like ethane. Now, when you react it with oxygen, here the products depends on the amount of oxygen. Now, if we take oxygen in limited amount, you will end up getting carbon dioxide plus water. Of course, you will be able to balance the chemical equation. Let's take now ethane with oxygen in excess. This oxygen gas, you will now end up getting carbon dioxide plus water, liquid. This is liquid. So these are the products of combustion between alkenes. So in general, we can be able to say that alkenes plus oxygen, you get carbon dioxide plus water. Also alkynes plus oxygen, you end up getting carbon dioxide plus water. So that is now the general equation for the combustion of alkenes and alkynes. Lastly, let us look at oxidation. Now let us look at oxidation. Now, when we talk about oxidation, we simply talk about the reaction between hydrocarbons with oxidizing agents like potassium permanganate, this is KMnO4, and potassium dichromate 6. Now, we all know that for oxidation reaction to take place, potassium permanganate changes from purple to colorless. Now, while potassium dichromate 6 changes from orange to green. This simply tests the presence of alkenes and alkynes. For example, if we take an alkene like ethene, then we oxidize it. The presence of KMnO4. Remember, it must be an acidified potassium permanganate. You will end up getting a double alcohol. So let us name this compound. This one will be ethane 1,2-diol. And this, the color of potassium permanganate will change from purple to colorless. And if you have used potassium dichromate 6, it will change from orange to green. Let us take a compound like an ethine. Let us take ethine. We react it with an oxidizing agent. Let's take acidified potassium dichromate 6. You will end up getting a double alcohol. the end. So this is simply the general equation is an alkene. When you oxidize it, this is oxidation, you end up getting a double alcohol. So that is simply the oxidation reaction among alkenes and alkynes. So in general, we can be able to say when we take hydrogenation reactions, we usually find that the alkenes will be able to turn into alkanes. When we go to halogenation, we'll be able to obtain haloalkanes. For the sake of alkynes, also we'll go into a step-by-step reaction to obtain first an haloalkene, then we go to a haloalkane. Under combustion, we simply talk about the reaction between hydrocarbons with oxygen, and the result is always carbon dioxide and water. Now under oxidation, simply we usually obtain the double alcohols, as I have already shown you here. So thank you for watching. Subscribe for more videos.